maintained enumeration and exploit toolsets for GCP red teamers. Scott's talk is called GCPwn, a Pentester's GCP tool. Let's give a warm welcome to Scott.
All right, per the intro, you already know the title of the talk. So I'm Scott, handles web and root, GCPwn, a Pentester's GCP tool. So a little about myself, kind of what was already said. I've had around 4-ish years experience in InfoSec. Those are some of the things I'm experienced in, some of the stuff I've done outside of work and just kind of projects I've worked on. So as you'll notice, one of the experiences is GCP. So over the last, I guess, 7 or 8 months, I really wanted to learn GCP, and I wanted to make a tool for GCP that was akin to Pacu for AWS by Rhino Security, which, if you're not familiar, is just a Python framework to test AWS. So I wanted to make a Python framework to test GCP, and in the process, kind of learn the GCP inner workings and SDKs. So over the past 8 or 9 months, I've made an open source free tool that is published under the NetSpy repo. Yes, everyone's 2 favorite words, open source and free. You can find it at the NetSpy GitHub repository. It's called GCPwn, as was stated before. And so some quick highlights. It supports ADC service credentials, standalone OAuth 2 tokens. It stores creds and allows you to swap between them. It runs in basically a modular format. So it's modules for different services, so storage, compute, functions, IAM, resource manager, etc. Since I gave this talk at CloudSec, since CloudSec, we've added a Docker file so you can run it in Docker. We've added the secrets manager, enum and exploit scripts, and some storage transfer enum capabilities. But I'm going to try to get through as much as I can in this talk, but there's a lot, and I'm not going to be able to get through all of it. So there is a wiki at that link at the bottom at gcpwn/wiki, and that goes through every module and how to load in creds and how to work the tool. So I would check that out if you want to review that later. But talking about a tool is really boring, and I assume a lot of you came here to see a demo. So if you don't understand GCP, some of this might be a bit confusing to you. I'm going to try to abstract it enough that you'll be able to understand generally what's going on. But I think this talk is recorded, and there will be a blog post, I believe, in a couple of weeks that will basically go through the same thing. So if you don't understand it now, don't worry. You can always review the recording later, or as you're learning GCP, kind of figure out what's going on at a later time. But the first step is basically initial access and tool setup. So as with any workflow in the tool, the first step is usually going to be finding credentials and loading them into the tool. So in this case, we're going to use the defcon32.gcpwn.demo2 user. And we're going to find creds for that user and load it into the tool, and then kind of off to the races running the modules. So assume you're on a pen test and you find creds right in a file on the desktop, and someone has just put their email and their password for a GCP. And it also mentions a service account in a project that will be applicable later. So the first thing we're going to do is when we find an email password, we want to put it into GCPwn, basically load the credentials into the tool. So this is basically me just setting up the tool. I set up a virtual environment and then just git clone the repo from the NetSpy repository, run the setup script, which is just basically a bunch of pip installs and installing the gcloud CLI, which is just the command line tool to interact with GCP. And then that will run. And then what we have to do with ADC credentials specifically is if you're not familiar, you have to sign in via the browser with email password with ADC credentials. So you can actually run this from in the tool, but what I'm doing now is running the gcloud auth login and gcloud application default login from outside the tool to log in, which will save our creds in the background. And we'll notice the creds do work, and we do have access to a project called My Private Test Project. We'll notice we have no organization, and all we can see is this specific project. And the project name is also important because you can set that at the command line via gcloud config. That's just how gcloud works. Again, you can do this all from within the tool, but I'm demoing doing it outside the tool because that seems to be the easier way to kind of load them in. So run gcloud application default, and it will now authenticate us. If you're ever interested in ADC and what that looks like kind of in the background, it basically saves a refresh token for you in a JSON file, and that refresh token is then used subsequently to fetch access tokens as you're running gcloud. Kind of a deep dive, don't need to worry about that too much, just if you're curious, that's what it looks like. But now we have our credentials installed at the CLI, and we want to load them into the tool. So we're just going to start the tool with Python main. It asks for a workspace name, just like Pacu, which is just a logical unit. You can call it whatever. And it gives you a huge help menu. So you have the link for the tool at the top. There's creds. So creds are basically how you load in creds. Remember, you can do service account, OAuth, whatever. You can swap between the creds. You can send creds to the token info endpoint. More on that later. You can set the email for the creds, which is applicable if it's doing IAM stuff. You can also add creds from within the tool. So like I said before, instead of adding them before starting the tool, you can add creds while you're in the tool. And you can also update creds, which is super useful if you have OAuth 2 creds and those expire at some point, and you want to update them with a fresh new set of OAuth 2 creds. You won't lose all the progress you've made on enumerating permissions. And you can also swap creds. And I think that's pretty much it for the creds. I'll touch on token info later, but the next part is modules, which we'll go to next. And so modules is how you actually run the code. So it's modules run the module name, and then GCPwn falls to a default project ID, which we'll see shortly. But if you have a manual one you want to specify, you can specify that at the command line, which is basically what it just shows there. And then projects, GCPwn keeps a global list of project IDs as you're working through it. If you find a project ID as part of a pen test and it's not auto-magically added to the tool, you can manually add that project ID and then run all the modules on it. And you can manage the projects from within the tool. That's a global list. It's not scoped to a specific user, so just keep that in mind when you're adding project IDs. And then the final part is just data tables. So as we're enumerating all the data, if you want to export that data or get the data from the tables, there's just a data tables command, and you can also export that. And then if you run gcloud, bq, or gsutil commands, those will just dump you to the command line, right? So not within the framework of the tool, but we could have run like gcloud auth login and all that stuff from within the tool, because it just runs it at the OS level. It will also list all the existing creds. So nice thing about GCPwn is once you add the creds, you don't have to add them again. And we'll see that later. They'll just pop up and you just choose them and you resume from where you left off. You can see it supports ADC creds, which is what we did. If you have a file with just the refresh token, you can also pass that in for ADC file. So if you just have a file that looks just like that and you just want to pass that in, that's also something you can pass in. And then the OAuth 2 token, just a standalone OAuth 2 token if you want to do that, and then service account credentials. In this case, we're just doing ADC, so you do ADC in the credential name, and you'll see it adds the credentials, it adds the project ID, it says it successfully added your ADC creds, and you'll see the command line for GCPwn. The first part is your default project ID. It will always fall back to, or usually fall back to for most modules. And then the second part is the name of the cred set, whatever you gave it. I think that's it for that. So we added our user to GCPwn, and so now we're going to take a look at that service account that was in the original note, because right now we're in our private test project, but we want to branch out into different projects. So that service account that we looked at before has a different project in its name. So we're going to run an exploit module to generate a service account key for that service account. One of the commands you'll be running a lot in GCPwn is called creds info, and that's like the who am I in this tool. It'll give you back the email, it'll give you back the scopes of your current set, it'll tell you your default project, show you the global list of projects, and it also gives you the access token, which is super nice because if there's an API that's not covered by this tool, Google usually has documentation that you can run the API and you just need to supply an access token, or even just using burp, I think, with the authorization header. So you can kind of copy that access token and use it in other places. If you base 64 that access token, it'll be a bunch of gibberish and you won't actually know who it belongs to. Google has an official endpoint called token info where you can send access tokens to, and it will return whose emails those access tokens belong to. So if you do creds token info, it will take your current OAuth token, send it to the token info endpoint, return it, which will tell you the email of that and the scopes. And if we run creds info again, you'll notice that it will have added that to your who am I profile, right? So now you have your email and your scope. You'll also notice though that the creds info doesn't have any permissions listed because we've just added these creds. So there are no permissions we know about. If you run modules, it lists all the modules, which is shown there. So modules are split up into enumeration and exploit. There's service-specific modules. So, most service-specific enumeration modules have common flags shared between them. One of those is --download, which we'll see shortly, which will download the respective data. So for enum buckets, it's going to try to download all the blobs. For enum secrets, it's going to try to download all the secrets. There's also service-specific flags for each enum. So enum buckets, you can pass in filter rejects to only download blobs with a specific regular expression. And with Secrets Manager, you can pass in like a version range to only try to enumerate secrets of a certain integer range. And then that's a pain in the butt, though, to run all these individual service enumeration scripts. So I just made one module called enum_all, which will be shown here, that you just run it and it runs all the enumeration scripts for you and it accepts those common flags. So if you want to try enumerating as much as you can and downloading as much data as you can, then you can just run enum_all with those flags and it'll run it all for you. It also supports the --IAM flag, which if you're not familiar, is test IAM permissions. So there's an API in Google called test IAM permissions, if you're not familiar with it, where you send Google a list of permissions, or you send GCP a list of permissions, and GCP will return the permissions your credentials have. You don't ever have to call those permissions. You just send in the list and it returns those. So that is supported across a bunch of different resources. And so if you add the --IAM flag, that will also call that in the background. The summary is basically if you add the --IAM flag, you'll get more permissions enumerated usually without actually having to ever call those permissions. So we're going to run enum_all with the --IAM flag and then save the output if you just want to save it. And we'll see it goes through and it enumerates all the resources. There's not a lot in this account because a lot of the APIs are deactivated, so you see a lot of 403s and that type of stuff. We were able to fetch our current project though, so we were able to make the GET request on that project. And now if we run creds info, yeah, you'll see if we run creds info, now it lists all the permissions our credentials have, and we got that just from running that one module because it called test IAM permissions on the project level and passed in a big batch of permissions, and then GCP returned the permissions our credentials were allowed to call, and then we just saved it to the profile. And the dangerous ones, right, are like highlighted red, so ones you might want to pay more attention to. So like set IAM policy, for example. And now that we have enumerated everything in this account, we want to look at the other account. So if we look at the service account has another project name in it. So we are going to manually add that project, we're going to run an exploit script to generate the service account key for that other service account. So you can search modules. So we search for exploit modules. We have one called exploit service account keys. You'll notice that if you do the -h flag, it tells you how to call the module. Most of the exploit modules, I tried to make them so if you pass in no flags, it will walk you through a wizard for like how to exploit stuff. And the way it does that is it will take all the data you've enumerated thus far and then give you a prompt. So in this case, like I ran exploit service account keys, but I didn't specify creating, enabling, or disabling it. So you pass in the service account key name, and then it prompts you, do you want to create a key? You say yes, so you just choose the one option. It says the key was successfully created. Do you want to try assuming the new creds? It's hard to see, but then yeah, you say yes, and now you are the new creds in the new account, and it's pretty much as easy as that. You'll notice the project ID didn't change. That's a bit of a bug, I think, at the moment. But if you need to change the project ID, you can always manually do that. Again, if it's like a bug like this, or you find it in some way. So that's basically what I'm doing here is I'm updating the project ID. Because yeah, we're in staging project 1 right now, and we only have my private test project, so I'm just going to manually add the project ID with project set, and then it switches, and now we are the new service account in the new project, and it was all done from within the tool, so you can just kind of walk through the wizard and step into the new value. Okay, and now we're going to look at a more complicated diagram. So we're going to start on the left. We are the MyDev service account. We're going to run enum_all to enumerate as much as we can. We're going to see that we have access to one bucket, right? The one in the top right, old development bucket. That's going to indicate that there are credentials in the service account details bucket, but we will not have access to that bucket, right? We're going to be blocked from list blob permissions. But the note that we're going to see is going to reference us to Secrets Manager. So we're going to enumerate Secrets Manager, pass in a wide range of numbers, because we don't have list permissions on Secrets Manager, we only have get. So we're going to pass in the secret name, a wide range of version numbers. We're going to get back HMAC keys. If you're not familiar with HMAC keys, they're a feature in GCP for storage accounts that allow you to list and download data using SigB4. So very similar to AWS, if you're familiar with that SigB4. And that is supported in the tool, as we'll see, and you basically run enum buckets with those keys, and it will enumerate and download everything for you, and that'll give us the final service account. So as, again, probably what you'll be running most of the time, we have our new credentials, we run enum all. When we run enum all, we'll see that we are able to see, because there's more than one project, it will prompt you if you want to run modules on all the projects or just your current one. We say our current one. You'll see it finds 2 buckets there. In one of the buckets, it actually finds a blob or a file in that bucket. The other bucket it can see, but it cannot list the blobs within that bucket. So what we're going to do is, if we want to download the data, we're going to run creds info first. So as you're running modules in GCP, it's passively seeing all the permissions you're allowed to do. So once we ran enum all, if we run creds info, notice it tells us we have list buckets permissions at the project level, and all like objects list permissions on specific buckets. So it's passively getting all those permissions for you. And this is data tables, like I referenced earlier, so you can run that to get all the data you've enumerated thus far. And it's not shown here, but you can also export that to a CSV file. So we're going to run enum buckets, and we are going to add the -- download flag, which is going to download the data for us. Any data you download from GCPwn gets put in a folder in the root called gathered data, which we'll see here shortly. And so if you go into gathered data and you just look at the files, you'll see that our file was downloaded. So if we cat the file, we'll see, like I said before, it's a note. Just to kind of summarize the note, it's saying, I moved the service key out of this bucket, and I put it in that other bucket you don't have access to, and I put the keys to get access to that bucket in the Secrets Manager under that specific secret name. And what you might be thinking is, when we did our enum all earlier, it didn't show any secrets in this account. And the reason for that is GCPwn by default will call list APIs first, followed by get APIs. So if you don't have list permissions, then it probably won't see it, but all the enumeration modules allow you to pass in specific resource names via flags. So because we have the name of the secret here, we'll be able to run enum secrets, specify the secret name, and then as part of that enumeration module, we can specify a range of like 1 through 100 for version numbers, and just see if it's able to find any. And this is just showing, so again, in enum all, no secrets were shown because we didn't have list permissions, so nothing was shown. But we're going to go ahead and manually run enum secrets with -- version range 1 through 20 and the keyword latest, and we'll specify the download flag to download that to our local desktop. And we run that, and you'll see it goes through all the numbers, and it's able to find secrets for the first 4. A lot of the standard output in the tool gets cut off at a character limit. So you'll see number 3 there, or version number 3 of this secret, has the Google HMAC key in there. But it's cut off at the moment, because again, standard output gets cut off in some places. But because we downloaded the file, we can just check the download for the full value. So if we go to the gathered data folder, which we should jump to in a second, and we look at the data again in gathered data. Now there's a new file there, secrets data file. If we cat that, we'll be able to get the full HMAC key. And like I said, with the HMAC key, you could use some vanilla Python to do some SigB4 stuff to call the XML API, which actually doesn't have an SDK in GCP, but that is all programmed into GCPwn. So you can run enum buckets. I'll pause it there. You can run enum buckets. Kind of hard to see at the top, but you can run enum buckets, and you can pass in flags -- access ID and -- HMAC secret, and it will take those and make all the SigB4 requests for you and list and download all the data. So we pass in the -- download flag. Now notice we can actually see files in that bucket that we couldn't see before. And if we go to gather data, you'll see that those files are now downloaded. And that will give us, let's see, what's the time? So that will give us another service account key, and then a note saying that service account can generate functions. And so I'll skim through the next part here because we're kind of short on time. But again, it gives you some hints. And then just to kind of summarize the rest. Let's see. This is just showing if you start the tool again. So if I start it fresh like the next day and I run it, you'll notice the creds we've already added are already listed there. So you have to put them in again. You can just choose the number to resume from where you left off. And we're just adding our creds for the ones we just found. So with service accounts, it's super easy. You don't have to do the gcloud auth-log and stuff. You just point the tool to the file and the service account gets loaded. I'm not going to have time to go through this, but basically there's also an exploit module to create a cloud function, attach a service account to it, and then call the metadata endpoint to get the OAuth credentials back for that service account, and then the tool will just prompt you, do you want to become the new user? You say yes, and you become the new user. And then the service account itself has create service account keys on itself, so then we just create a service account key for ourselves because OAuth 2 credentials expire at some point, and a service account key does not, or usually doesn't as much. So just skimming through it, some worthy things to note is when you enumerate all the data. Okay, perfect. Yeah, so when you run the exploit module, which I can't show everything here, but when you run enum all, it populates all those tables for you in the background. So when we run exploit cloud functions with no flags except for one where I'm hosting my payload, you'll notice it just walks you through a wizard. So it asks, do you want to create the function? You say yes. Then it asks, what's the function name? You can pass these all in at the command line, but the tool tries to walk you through it. And then at the end, it gives you all the service accounts that's enumerated thus far and just asks, like, choose one to try to add to the cloud function. You choose that, and it'll try to add it. And that basically just gives us OAuth creds at the end. And then it'll just ask us if we want to become the new user. Something else to note, when you're running all these modules, it's saving granular permissions in the background. So the tool will track granular permissions, but if you have IAM permissions, you can also just grab the roles for all the users, right? You don't really have to do any guesswork. So if you have IAM permissions, enum all will grab all the IAM policy bindings at the end that it can. And then if you run process IAM bindings, which is shown there, it will take all those IAM bindings and print them out in an easy to read format. It supports text and CSV outputs. And then, won't be able to cover this, but basically implicit delegation is also supported. So if you run a module, if you're not familiar with implicit delegation, that basically means test bench service account multi has the token creator permissions on role just for testing, and role just for testing has the token creator permissions on production functions role. So you can basically skip the middleman and just go from the test bench account to the production functions role. The reason I included this is because the exploit module I made has some pathfinding capabilities. So when you enumerate everything and you run process IAM bindings and you kind of pick up that this is here, when you run everything, if you add the -- all delegation flag, it will just find all the impersonation routes for you that it knows at this point in time, and then you can just choose the impersonation route you want. So in this case, we choose 2, and it will just give you back the OAuth token, and then ask if you want to become that user. So that's the route we would choose, and again, I just passed in all delegation. It found that flag, pass it in, it gives you the access token, says you want to be the new user, yes, and then you just kind of rinse and repeat with enum all and all that stuff. So as you can probably tell, I wasn't able to cover everything in this talk. One interesting aspect of this that at least I think is interesting is that test IAM permissions endpoint I brought up earlier. You can run that at the project level. So if you're like from the AWS world, imagine this is like if you found AWS creds and you wanted to know what the permissions were for those creds in that AWS account, then you can basically do something like this, where in GCP, you can pass in around 9,500 permissions at the project level. You don't need any authorization to call this API because the API that returns the permissions you have in of itself doesn't have permissions to call it. Which is, I find, pretty fun. So you can run this tool, and I wrote something in Hacking the Cloud, which is made by Nick, So you can take a screenshot of this link or something, or check it out later. I also have it in the wiki, but you basically can run the tool with certain flags if you find GCP leak creds, and you can come back like a half hour later, and in a lot of cases it will tell you exactly what granular permissions you have without ever having to actually call those permissions. And it's also same thing on the GCPwn wiki. I have some common use cases that I think will fit 90% of people's use cases, and one of those is this brute force permissions path, and so it's listed on there as well. So again, I encourage you to check out the wiki. Some upcoming stuff, I'll be updating the wiki, some more services being added, just general updates. Just following the GitHub repo, you should see the updates as they pop up. All right, and that's the end.